All right, welcome back. So 6.9, integration by parts. So this is a continuation on from what we did with the last stuff. The last one we did some substitution. That was to undo chain rule. And so when we made a substitution, we picked our substitution to be your inner function. So for chain rule, that's what we were undoing when we integrated that. Earlier on, we did power rule, which ended up being kind of mechanical and straightforward, if nothing else, but there was some hard and fast rules for that. And so that's kind of what happened with that. Some easy trigonometric and exponential functions. We've looked at some of those things. But now what we're going to look at next is product rule. And so how would we take our integration of what we'll end up looking at is the integral of f of x g prime of x dx. And the reason that we're going to look at that with the f of x and g prime of x instead of just f of x g of x comes from the fact of well, let's derive this and see where this comes from. So this starts off by saying, okay, so your derivative of f of x g of x is equal to f prime of x g of x plus g prime of x f of x, or commonly we're writing that the other way around, but this is how it ends up being. Regardless, it's the derivative of one of those pieces and not the other, plus the derivative of the other one instead. And so that was product rule. So to undo this differentiation, we take our antiderivative by anti-differentiation. Another way to say anti-differentiate is to integrate. Is what we're doing here. And if I integrate both sides of that, then the integral of d dx of f of x g of x with respect to x, so dx, is equal to the integral of the right side, so the integral of f prime of x g of x plus g prime of x f of x, and then dx on the end. Now on the left side, we have the integral of the differentiation of f of x g of x. So the left side is just f of x g of x. Whereas the right side, we can break it apart into two differentiations, and let's call it the integral of f prime x gx plus the integral of g prime x f of x. Each of these, of course, with our dx term. And if we rearrange it and solve it for this one, if we rearrange it and solve it for that one, we have that the integral of f of x g prime of x will equal f of x g of x, so just those original two functions, minus the integral of f prime of x g of x dx. So what we're going to look for, therefore, is we're going to look for, if we're trying to differentiate one of these pieces, the f of x, we're going to differentiate it, and one of the pieces, the g prime, we're going to anti-differentiate that. And so if we have ln x dx, if we call our function f, if we call that ln x, then the derivative of that is 1 over x. Our g prime is just 1 dx. So here was your f, is ln x. Here's your g prime, is just 1 dx. And so when I anti-differentiate 1 dx, we get x. So putting this all together, we have the integral of ln x dx is equal to f times g. So ln x times g of x, which is x. We should probably write that out in front just to make sure we're clear that that doesn't mean ln of x squared. That means x times ln of x. And then we're going to subtract the integral of 1 over x times g of x dx, which is equal to x ln x minus, and this is just your integral of 1, so that's x. This indefinite integral, so we need the plus c on the end, and that's it. So we often will use a simpler notation than have all of this in terms of f instead of function notation. More commonly, we will see this using u and v. So if we let u and v be differentiable functions of f, then your product rule, well, the derivative of u times v is u times dv dx plus v times du dx. And if we integrate both sides of that, similar to what we just did up above, then the left side will equal this, the integral of d dx of uv dx. And the integral of the right side will be the integral of u dv dx plus v du dx with respect to x. This ends up being equal to the fact that uv is equal to the integral of u dv plus the integral of v du. And then rearranging this, so this is exactly what we did up above. Rearranging this, the integral of u dv will equal uv minus the integral of v du. Ends up being a little easier to memorize and remember and to work with. Should point out here that this above formula has 4 unknowns. We have u and du, and we have v and we have dv. 2 of these, we're gonna assign this to the original stuff. So this will be the original question, will be the integral of u times dv. The other variables, v and du, we're going to determine by integrating and by differentiating dv and u respectively. In general, u is a function that will eventually differentiate to 0, and dv is usually a function that's easy to integrate. All right, so what should we use in here? We have the integral of x cubed ln x dx. So we start off by saying let u equal. U is the one that we're going to differentiate. So let's call u is equal to ln x. Therefore, we have let dv equal the rest of it. So if u is ln x, then dv is going to be x cubed dx. I differentiate the u, and we get du is equal to 1 over x dx. And the dv, we integrate, and we have x cubed dx, so we integrate that, and we get v equals x to the 4 over 4. So after constructing those pieces, therefore, this question, the integral of x cubed ln x dx, is equal to the integral of u is ln x, and the other part's x cubed dx is dv. So this is the integral of u times dv, which is equal to u times v minus the integral of v times du. We put those pieces in. This is equal to x to the 4 ln x over 4 minus the integral of x to the 4 over 4 times 1 over x dx. We can tidy that up a little bit before we integrate that. This is equal to x to the 4 ln x over 4 minus the integral of x cubed over 4 dx, which is x to the 4 ln x over 4 minus, add 1 to the exponent, multiply the denominator by that, and we need plus c. So in question number 2, often what we're going to look for is we're going to look for the fact that u is going to differentiate away. If it gets a lot simpler that way, that makes us happy. So if u is just equal to this term of x, then du is equal to dx. dv will end up being the other piece of this. It'll be the 1 minus 5x to the 7 dx. If I anti-differentiate that, so just v is going to be equal to 1 minus 5x. Add 1 to the exponent, and we divide by that. And we're also going to divide by the derivative of the inside part, which is negative 5. So therefore, the integral of u dv is going to be equal to uv minus the integral of v du. And we start to drop these pieces in. U is just x, v is 1 minus 5x all to the 8 divided by negative 40. We're going to subtract the integral of 1 minus 5x to the 8 over negative 40 times du, which is dx. This ends up being equal to, let's leave this first term as is, 1 minus 5x to the 8, x times that over negative 40. And we find our integral of 1 minus 5x. This is now to the 9. This is over negative 40. We have to divide by our new exponent. and we have to divide by the derivative of negative 5x. This is plus c. And this equals just to tidy this up a bit, x times 1 minus 5x to the 8 over negative 40 minus 1 minus 5x to the 9 over 1800 plus c. Number 3. 2x cos of 6x dx. So let's make our substitutions. Let's let u equal x. du equals dx. Nice and straightforward. Let's not worry about that constant. We'll just leave it floating there for now. So if that's my du, then dv ends up being the rest of it. So dv equals cos 6x dx. V is the antiderivative of that. The antiderivative of cos is sine, but we also have to chain rule and divide out the derivative of 6x, which is 6. So sine 6x over 6. Therefore, now we need to be careful with this. The original question, don't forget about the fact that we have this constant of 2 here. So this is the integral of 2 times u dv. Ends up being equal to 2 times uv minus integral of v du. Ends up being equal to 2 times x times sine 6x all over 6. So we divide out the 2. That's x sine 6x over 3. We're going to subtract. I'm just going to write that 2 here so I don't forget about it. The integral of v. So the integral of sine 6x over 6 dx. Ends up being equal to x sine 6x over 3 minus the integral. I'm going to simplify that 2 over 6. And we want the integral of sine. And we'll integrate that. That's negative cos. So let's change this to plus. And let's integrate that. So plus cos 6x. It was already over 3, this 2 over 6. But when we integrate sine 6x, we get negative cos 6x over the derivative of 6x. So that's times 6 down there. And at this point, we need to have plus c on the end. So x sine 6x thirds plus cos 6x over 18 plus c. Last one. Again, let's let u just equal x. So therefore, du equals dx. dv is equal to e to the x dx. And so v is just e to the x. So some people remember how this works by if take our if we take what we've written here in terms of u and v, and so we have the integral of u times dv. This will equal, so u times v is just going to be those two if we always set it up this way in this kind of rectangular array of u and du and dv and v. And so u times v is going to be our first term. So this ends up being x times e to the x, and then minus the integral of, and it's just going to be those two, v times du. So this ends up being the integral of e to the x dx. This ends up being really quite nice, this one. X times e to the x minus e to the x plus c. And that's it. If you have any questions, please let me know, as always, and good luck.